In this video, we're going to be talking about how to solve problems where they ask you to differentiate using first principles. In order for us to do this, I'm going to be using an example to demonstrate the process. And this example is taken from the 2024 paper 1 from May. So this is a supplementary exam. And we're going to be using question 3 from that paper. We're only working on part 1 of question 3, which just asks for first principles. We're not going to go any further than this particular question. And part A basically says, using first principle, find the first derivative of f of x, and f of x is equal to x squared minus x, right? So we're doing first principles. And in order for us to do this, let's just remind ourselves, right? So I'm going to take us back to the explanation of what exactly first principles is. Essentially, first principles is using the long way of differentiating. So in order for us to do this, we have to understand what exactly is happening with differentiation, and that takes us back to the basics. So you may have heard this a few times at this point, but differentiation is the process of calculating gradient. So when you're differentiating a function, you're basically finding its gradient. So what exactly is gradient, right? So we know from our basic coordinate geometry that if you're given a straight line, right? So let's just say you're given this straight line. In order for us to find the gradient, we need 2 points. Point number 2, point number 1. And to calculate the gradient of this graph, we take the change in y divided by the change in x. So we say, okay, I want to find the difference between the two y values. So the y point at point number 2 minus the y point at point number 1. Same thing with the x's. I also want to find the difference in the x's, right? So I want to find, x2 minus x1. I want to find the difference between those two. So how we can illustrate that is with this triangle. I think you might have seen this in the past, where we say, let me just move this a little bit. Let's just move this a little bit down. All right, just like that. All right, let's take this back here. All right, so you might have seen this expression, right, where it goes. So this is your change in y because it tells you how far up it goes. It tells you the difference between the y points, and this is your change in x because it tells you how far it goes from point 1 to point 2 horizontally. So basically, this is what we're doing for differentiation. And first principles, even though now we're working with equations that aren't straight line equations. So this f of x is not really a straight line graph. It's not a y is equal to mx plus c graph. It still follows the same principles. All right, we're still building on the same blocks here. So in this case, how it works is this, right? We have a function. So I'm going to draw a generic function. So this might not be what this one looks like exactly, but I usually like just to visualize these just by drawing a generic, quadratic equation. So no matter what this says, I'll always just draw a basic quadratic equation, right? So in order for us to find gradient, we need 2 points. I'm going to take this point, I'm going to take that point. I'm going to call that point number 1. We're going to call that point number 2. Actually, let's just do this instead. I am going to draw this like this. So this is y, and this is x. We're going to draw our graph above the line, like that maybe. Let's just draw it like this. And again, we still need our point number 1, which is going to be here. And we need point number 2, which is going to be right there. Okay, so we're going to do the same thing that we did here, even though it's not a straight line, right? So we'll address the whole, this is not a curve, this is a straight line. I mean, this is, the difference between the curve and the straight line in a bit. But for now, let's just assume we want to use the same exact equation where we say, okay, in order for me to calculate gradient, which is, the derivative, in order for me to calculate gradient, I still need, so let's just switch to black now. Actually, no, let's just stick to blue. My gradient is going to be my change in y divided by my change in x. Okay, so what is the change in y in this case, right? In order for us to get the change in y, let's talk about the expressions, right? Instead of y, a function can also be written as, your y can also be written as f of x, because f of x gives you the output of the graph. So in this case, this can also be written as equal to y, right? So f of x is the same as y because it's the output of a graph. So when we talk about the change in y, we can also talk about your fx at this point and then your f of x at that point as well. So what we're going to do is we're going to go to our graph and we're going to say, okay, let's say this point has x value x, right? And then I move a certain amount to the right to get to my x value for point number 2. And let's just say I move a distance of delta h, right? So you just moved, so delta h just tells you like a step that you've moved, right? So which means when you get to this point, your x value is actually x plus delta h. All right, so maybe you came from 2 and then you added like 0.5, so now you're at 2.5, right? So that means at this point over here, your y value, instead of saying y, we can just say f of x. Essentially, we're saying the x value of this, of the function at this point is just, you put your x into your function to get the y value out, right? And then at this point over here, instead of saying f of x, because your input isn't x anymore, your input is now f of x plus delta h, right? So basically, so, maybe we're using too many letters here. Remember, your f of x expression tells you that this is your f value that you get out depending on your x input. So for example, if I say my x value is equal to 2, right, I can put 2 inside here. This means that my x value is equal to 2. So whatever your x value is at that point, that's what goes into your graph, and it determines your y value that you get in your output. So if our x value at this point is x, that means this is f of x. If our x value at this point is x plus delta h, it means it's f of x plus delta h, because this, what goes into this bracket, is your x value. I hope that makes sense. All right, let's just take there's too much going on in that. All right, cool. So now we know that we've got 2 points, right? Our 2 points are, let me just write these a little bit more clearer. So our 2 points are going to be this point here, which is going to be your x value is x plus delta h, and your y value is f of x plus delta h. And then you have a second point over here where your x value is x, your y value is f of x. All right, so that means when we now want to just delete these, when we now want to put these into our equation, we can then say, okay, my change in y is going to be, okay, what are my y values? This is my first y value, which is f of x plus delta h. And then my other y value is going to be this one. So you subtract f of x, because we're subtracting the 2 y values. Our first y value is this one, our second y value is that one. And then we're going to do the exact same thing with our x's, right? Our x for this point is x plus delta h. Our x for that other point is just an x. So we're going to subtract. All right. So basically, this explanation gives us all of the stuff that I've just said at this point is just an explanation of what first principle is. From this point, if you're going to take anything from this video, just know that in order for you to use first principles, just use this formula, and then you're good to go. All right. As long as you apply this formula, you apply it correctly, then you're fine, right? So now let's talk about how to apply it in this case. So we're running out of space over here. So I'm going to go all the way down to the bottom, and let's just say 3.a. So f of x is equal to x squared minus x, I think. Let me just scroll up to confirm. Yeah. Okay, cool. So now we're very quickly going to run through how to apply our derivative using first principles. Now we said the equation is f of x plus delta h minus f of x all over x plus delta h, which is the x value at this point, minus x. All right. Now, how do you then apply this to your formula? Now, the question is, what exactly does this mean? How does this relate to our equation? So the moment we were given f of x, which means x is your input. But the moment we change this to f of x plus delta h, it means x plus delta h replaces your input. It replaces x in the equation. So I'm just going to write this on the side over here. I'm just draw an arrow here. F x plus delta h. This is how you solve that. Instead of saying, remember, the easiest way to remember this is wherever you have x, just replace it with x plus delta h. So over here we have x squared. Instead of having x squared, now we have x plus delta h squared. And then minus x, but remember, it's not just minus x. You're replacing wherever you find an x, replace it with x plus delta h. All right, so that's how you do that. So we're going to put it into our equation now. So that's going to be x plus delta h squared minus x plus delta h. So that's just this first part, right? So now we still need to subtract f of x, which is x squared minus x. Remember, you have to subtract the whole thing. You have to subtract your whole f of x expression. So now we've dealt with the top, so now let's do the bottom. All right, so the bottom is still x. So the good thing about this one is you don't really have to do much, right? So your x is already taken care of. All right, next thing, now we need to simplify the top, right? So now we need to square this first one. So to square that one, you say x times x, which is x squared. Then you say x times delta h, which gives you x delta h. But remember, that's going to pop up twice. So you're going to have, let me just say 2 delta h times x. If you want to do it the long way around, you can go ahead and do that. That's perfectly fine. And then that's going to be delta h squared. So that's your first bracket. And then you still subtract x. Remember, this subtraction is going to affect this term, and it's also going to affect that term as well. So that's minus x minus delta h. And then same thing here, right? So this negative sign is going to multiply by this term, but it's also going to be multiplied by that term as well. So that expression is going to be minus x squared, and then negative times negative is positive x. All right, perfect. And then divide by x plus delta h minus x. Then we're going to group our like terms. So the good thing at this point is that at this point, your terms are supposed to cancel. And it is good because at this point, if your terms aren't canceling properly, you can very quickly see that you're going wrong, and then you can, basically correct your mistakes. Don't panic. Usually, it happens all the time, so it's perfectly fine. But you start to group your like terms, and they should start to cancel. So for example, I look at my x squared term, I look for another x squared term. I'm seeing there's another one here. So both of them, you've got positive x squared, negative x squared minus x squared, those cancel. Same thing with this x term, negative x plus x, those two are going to cancel. This one, it doesn't have like terms, that's fine. But at the bottom, you see again, there's a positive x minus x, that cancels. So what we have left after that is 2 delta h times x plus delta h squared minus delta h. At this point, you should have terms with just delta h's, because at the bottom, we have a delta h that's supposed to cancel with those ones. So what you want to look for all the time in these questions is the top should always have delta h's throughout, so that if you have a delta h here, a delta h here, a delta h there, you can factor out that delta h. So that in our case, it becomes, so if I factor out delta h from there, it becomes 2x. Factor out the delta h, we've only removed one of them, so we are left with just the other one. Over here, if I remove the delta h, I'm left with just the negative, and then we have a 1. This is over delta h. And the reason why I say it should show you if you've done the right thing is because the delta h here should cancel with the one at the bottom. Doesn't matter if you still have one inside, that's still fine, but the one at the bottom should cancel. So at this point, all we have now is 2x plus delta h minus 1. This brings us back all the way to our equation at the beginning, right? So we said in this case, we just took 2 points, said point number 1 and point number 2. But this is not a straight line, because if I draw a straight line, it's actually, because this is supposed to be used for a straight line. But this doesn't actually work, because you see here, there's all this room. It doesn't describe the graph properly, because as you can see, it leaves all the space between the graph and an actual straight line. However, if we make this gap really small. And this is the principle. What basically happens with differentiation. It says, yes, we assumed there was a step, but if we made this step really small, let's just say the step was there. See, it's now a lot closer to being on the line, right? So what if the step was so small? What if delta H was so small that we can approximate it to zero? We can assume that it's very close to zero so that it's negligible, right? Essentially, that makes our differentiation much more accurate. Then we can use this equation with a lot more confidence. So that's where we say we have to limit delta H to zero, right? Delta H tends to zero, which basically says, okay, we've assumed that it's a straight line between 2 points, but let's just make sure that delta H is so small that the distance between the 2 points lies on the graph so that it's not too big of a step so that there's all this inaccuracies here. So just going back to our question, if we apply the limit that delta H tends to zero, it means this delta H is so small that it's negligible, which means right now we can just cancel it out because, it's that small. So all we're left with is 2x minus 1. And that is your derivative from first principles. And then what you can then do is just always make sure that if you find the derivative of this using basic rules of differentiation. So for example, if I take that and I say, okay, f of x is equal to x squared minus x, use basic laws of differentiation that say, okay, I've got this power, take the power down to get 2, and then subtract 1 from the old power, that gives me 1. Same thing with x, which is the same as x to the power of 1. Take down the 1 to give me 1, and then you've got x to the power of 0. So that's going to be 2x minus x to the power of 0 is just the same as saying 1. So this is 1 times 1. So this is 2x minus 1. So the good thing is we can always just check if our answer is correct using other methods. But the thing that you need to remember with first principles is, yes, I've explained where this comes from. But as long as in your exam, you can apply that properly, and usually the mistake comes in when you put this x plus delta H and you apply it wrongly, right? It's very easy to make a mistake there. But the good thing is that we've got checks along the way, right? Things are supposed to cancel. You're supposed to get to, especially when you get to this point and you're seeing that your delta H isn't canceling, then you probably just made a mistake somewhere. But all of this comes with a lot of practice. So that is the one thing that I encourage students to always practice as much as possible, just so that you can identify these things in your exam especially. All right. So I hope this video was helpful. We went into it in depth a little bit. So the video became long, but I hope it was helpful, and I'll see you in the next one.